Look at these fun gingerbread biscuits. What do you see? Same dough, same ingredients, same oven. Very different results. Each biscuit tells its own story. Is this a person? It's got no mouth. Maybe they're wearing glasses. Is this somebody in a uniform? Who knows? We're taught to recognise things in the world through our experience, to know that something like this, even though it's only a head, probably represents a person. And maybe this is a clock face. Perhaps this represents a snail. What about this one? Maybe some kind of patchwork? Who knows? It's the same with AI. We have to train it to recognise things in the world by allowing it to experience these. We train it with data, and the data that we use to train it dictates the patterns that it's able to see in the world. Sometimes it sees things that aren't there because we haven't trained it appropriately. Today, we're going to look at data, patterns, how AI sees the world, why it gets things right, why it gets things wrong, and why bias in what it does, what it sees, is as fundamental as the cookie cutter that we used for each of these biscuits. Welcome to Rose's AI, where we bake and we learn about artificial intelligence. We've already learnt about the 3 fundamental ingredients that are common to all machine learning AI: data, processing power, algorithms. We did all that with the humble Yorkshire pudding. We've also learnt that a neural network is a way in which artificial intelligence learns from data. And we did that with the layers of a Victoria sandwich. Today, we're going to bake delicious gingerbread cookies and learn about how AI sees the world. This is Rose's AI. Let's get baking and learning. Like all good things, it starts with quality ingredients. So in the mixer, I've got 350 grams of plain flour, a teaspoon of bicarbonate of soda, a teaspoon of cinnamon, 2 teaspoons of ginger, and half a teaspoon of mixed spice because I really like a little bit of extra spice in the biscuit. And then I've added 125 grams of butter, cut into cubes and cold from the fridge. Now I've started to mix it together with my hands to turn it into breadcrumbs. You could just use the mixer, but I personally like to use my hands to start off with because I like the feel of the dough and I find it very relaxing. So think of this dough that we're building as the training data that an AI system is going to learn from. And the quality of the data will dictate the quality of the AI system that results from the training. So I'm just going to turn the mixer on and turn that into fine breadcrumbs. So we've now mixed that enough that we've got fine breadcrumbs. So the next ingredients to add is 175 grams of soft brown sugar through the chute here, and that will mix in nicely. Good quality ingredients are fundamentally important to getting a really nice ginger biscuit, and it's true with artificial intelligence. Good quality data, we're much more likely to get a good outcome from our AI system. We've got these dry ingredients in there, they've been mixed together, but we need something to bind it all together. Now with our gingerbread cookies, the binding ingredient is 1 egg beaten and 4 tablespoons of golden syrup. Something that I do when I'm using golden syrup in cooking, because it's so sticky, is I soak my tablespoon in really hot water, and that helps the golden syrup to slip off the spoon nicely. 4 generous spoons of golden syrup, because we certainly want the dough to be bound together really nicely. Now you can think about this ingredient that binds our dough together as being a little bit like the labels in a data set. So when we're training an AI, maybe to recognise cats' faces, we give it thousands of examples of different types of cats' faces, each of which is labelled as a cat face, so that when the AI is shown the data, when it's fed the data and it experiences that data, it can associate that pattern with the label cat's face. The binding, the labelling, is what enables the AI to learn from the data that we're training it on. And so we can think of this as the binding ingredient. So let's just pop that in the machine. Okay, that looks like that's kneaded enough. So let's take it out of the mixer. Now it's important for the biscuits not to knead the dough too much because you want it to stay flexible. That means not over kneading it. Now, it's similar with our AI and its training data. We don't want it to become inflexible, just like the dough would become if I kept kneading it too much, because we don't want it to only recognise a particular example of, say, a cat's face as being a cat's face. We need it to be able to generalise. So for example, if we were training a system to learn about architecture and we only gave it examples of modern architecture and we trained it and trained it and trained it, it might only recognise particular architectural features involving steel and glass, for example. It might not recognise this as a person because it's been trained only to recognise a person as looking precisely like this. We mustn't overtrain the data because it's really important that it can generalise. Now what we're going to do next with this lovely dough, looks absolutely great, is pop it in some cling film and put it in the fridge for half an hour. Let's talk about the next step, which is where we roll it out and we impose patterns on the dough with our cookie cutters. And we do exactly the same when we're using data to train our AI systems. We've bound it together with the labels. Now we need to impose the patterns to say, this is a person. We might have a cutter like this. We might also have a cutter like this, which is a bird, or one like this, which is a sort of dinosaur. Lots of different sizes. So we can create or impose lots of different patterns on the dough. And it's just the same when we're training our AI systems. But we need our AI systems to have a very flexible understanding of a particular object. So we might label this object person, but we need the AI to know that when it's angled like this, it's also a person. When it's angled like this, it's also a person. When it's got an arm in the air, it's also a person. So we have to do a lot of training to make sure the AI sees enough different examples to be able to accurately recognise items in the world. But as I said when we were mixing the dough, we have to be careful not to overfit the data so that it only recognises one very specific sort of person as a person. Now, let's go and get the dough from the fridge and roll it out and start making some cookies. Right, so I've got my dough from the fridge, it's cooled and it's just right for rolling. So now I'm going to carefully and gently roll it out until about 1/4 inch thick, turning it a quarter turn each time. Try and keep that rolling even so that we impose an even pattern. Let's try. Okay, there's a lovely gingerbread man. Place it on the baking tray. Another one. Ring as well. And then once we've got them all cut out, pop it in the oven, 180 degrees, about 12 minutes, but I always look after 10 just to see how they're doing. Now our beautiful biscuits are nicely baked, and as you can see, I've already decorated them. They all came out of the oven looking much the same, but in decorating them, I impose particular features on them, and that will influence the way that you interpret them. Will you see this person as a ballet dancer because they have a frilly skirt? Will you see it as something different? Will you see this one as a clock face, or will you see it as a biscuit with a boomerang on it? Now let's imagine that we've trained our AI network and we're now showing it images that we want it to recognise. So we show it the person and it fails to recognise this person because its training data was biased towards people who look like this. And this is one of the challenges that we have. Our machine learning AI systems can only pattern match, and if they don't have a pattern to match to in their training data, then they have to guess based on probabilities from what they have been trained on, what it is we might be showing them. Maybe they will guess correctly that this is a person, but perhaps they won't. Maybe they'll guess correctly that this is meant to be a clock face. Maybe they won't. And so the limitations of our machine learning AI systems are within the data on which they've been trained. So what does all this mean for you? 3 things. First, question the patterns when you're using an AI system. Next time you ask your favourite AI tool to complete a task for you, look at what it produces and ask yourself, what pattern did it match to get this answer? What cookie cutter did it use to reach that answer? Second, recognise the difficulty that AI has with ambiguity. And don't rely on the answers it gives you when you ask it to deal with something ambiguous or something unusual. If it comes back to you with a very confident answer, that should be a red flag for you to look and make sure that what it's telling you is accurate. Because if what you're asking is ambiguous or abstract, it may well not have been trained on data that gives the right pattern to match to give you your answer. And third, understand bias is baked in. When I chose to cut this cookie in this shape and then bake it in the oven, I baked that shape in. When I chose to decorate it in this particular way, I biased your perception of it towards a particular type of person. So remember that when you're dealing with an AI system that uses machine learning, any bias will have been baked in, so to speak, in the data that machine learning AI system has been trained on, the way that it has learnt. Your challenge for this week is to set your favourite AI system an ambiguous task. Ask it to deal with something or produce something abstract and ambiguous, and then look at what it produces and ask yourself, what pattern has this system tried to match to in order to answer my question? In the next episode, we'll look at bread, and in particular, sourdough. We'll take a sourdough starter and look at how it learns, improves, succeeds and fails, just like an AI system. And remember what you've learnt today through our cookie example about training data and how an AI can only see the patterns that it has learnt as it's been trained. Yes, it can improve, it can constantly improve, but it can only learn from the patterns that it's trained to see. Understand its limitations and understand its strengths. It can do amazing things like diagnosing serious diseases, but it can also see things that aren't there, hallucinate and make things up. Subscribe to Rose's AI to learn about AI one delicious bite at a time. And remember that with baking, just like artificial intelligence, we bake the patterns in and they shape the stories that we tell.